Welcome students. Today we are going to learn about the small signal models of BJT and FET amplifiers. Myself Dr. KIRTI VYAS from Arya College of Engineering IT. So let's get started with the lecture. The BJT transistor modeling. A model is an equivalent circuit that represents the AC characteristic of the transistor. A model uses circuit elements that approximate the behavior of the transistor. There are two models commonly used in small signal AC analysis of a transistor. First is the DC model, which is used for the operating point. This one is not used for the AC analysis, but it has been used to find out the value of IC and VCEQ in the BJT circuit. And second is hybrid equivalent model. Now here we can see the BJT as a two-port network. The two-port network is comprising of input port and the output port labeled as 1, 1 plus and 2, 2 plus respectively. The two-port model, the AC equivalent model, is drawn on the basis of two equations, where the first equation is Vi equals to H11 I1 plus H12 VO, and output current IO is equals to H21 II plus H22 VO. Here H11, H12, H21, H22 are replaced by HI, HR, HF and HO, where all these H parameters are referring to a specific characteristic of the transistor. HI is the input resistance, HR is the reverse voltage gain, HF is the forward current gain, and HO is the output admittance. Since the model has been drawn by using hybrid parameters, where the units of each parameter is different, that is why the model is also known as hybrid model of BJT. This is how we can determine the H parameter models. The hybrid equivalent circuit models for different configurations such as common base and common emitter configuration can be drawn by keeping either the base common, and for the common emitter keeping the emitter common. Now we start with the analysis of the transistor model using H parameter. For the analysis of the transistor amplifier, we will determine the following terms: current gain, voltage gain, input impedance and the output impedance. Applying the KVL in the circuit, we will find the current gain, which is equals to minus HF upon 1 plus HO RL. The voltage gain can also be derived by using the KVLs and KCL inside the circuit, and also the input impedance values. The output impedance value can also be derived by setting the source Vs to 0 and allowing a voltage source connected to the output terminal, and finding the expression V0 upon I0. The small signal model of FET is represented by ID is equals to GM VGS plus VDS upon RD. Here This circuit represents the AC small signal model for FET. For drawing the AC equivalent circuit of an amplifier, we have to assume all the capacitors as the short circuit element for AC analysis, short circuit the DC supply and replace the FET by its small signal model. This is how the analysis of a CS amplifier can be done, and we can find out the voltage gain, input impedance and the output impedance. The analysis of the CS amplifier with potential divider bias can also be done as shown in the slide, where voltage gain is equals to negative Gm into Rd. An amplifier circuit using MOSFET, the common source amplifier, has been shown in the slide. A small signal equivalent circuit of CS amplifier can be drawn by appropriate positioning of all the biasing resistor used in the circuit. This is the equivalent circuit used to find the output resistance of the source follower. Similarly, we can have a common gate amplifier, and here we are summarizing the common source, common gate and common drain type of amplifiers. The above configuration is emitter follower because its voltage gain is nearly equal to unity, that is V output is equals to V input, which means change in input voltage is nearly equal to the change in output voltage. For this particular configuration, if we perform the AC analysis, we will have the different values for current gain AI, input impedance Zi, voltage gain AV and output admittance Y0, which are given as the equation in this slide. Thank you.